Welcome back. Let's talk about deserts. There's actually 5 different main types of deserts. Not all deserts are the same. And typically we distinguish them based on their location, global air circulation patterns. So different deserts form in different ways. So that's how we kind of define them out. So again, depending on the location of the desert relative to wind patterns, water patterns, currents, locations on Earth. So that's what dictates these 5 different types of deserts. And they are, and we'll just go through the list and kind of do them one by one, subtropical deserts, polar deserts, continental interior deserts, rain shadow deserts, and coastal deserts. So let's talk about the first two because they kind of form via the same process. So subtropical and polar deserts. Both of these types of deserts form due to descending atmospheric, cold, and dry air. Without getting too much into it, the physics of hot versus cold air, meteorology, climatology, which are all separate classes, just know that cold air holds less moisture. Warmer air can hold more moisture, cold air can hold less moisture. It's just a thermodynamic property of H2O molecules in the atmosphere and other gases in the atmosphere. It is what it is, all right? So, subtropical deserts are located around 30 degrees north and south latitude. Polar deserts are located in polar regions. And both of these areas are located on the Earth where in the atmosphere, cool and dry air descends from the upper atmosphere over these areas. Since cool air is descending over these areas and cool air holds less moisture, therefore there's no moisture in the atmosphere, so you're going to have an arid region, dry arid region. You're not going to have a lot of precipitation. Excuse me. So as far as latitude and longitude are concerned, latitude are the kind of measurement lines that run horizontal laterally around the Earth. The equator is kind of the measurement of where we measure latitude from. Latitudes measure either something degrees north of the equator up to 90 degrees or degrees south of the equator. Longitudes measurements are measured from the prime meridian, just a fictitious circle that goes around the globe, and you're looking at how far either west or east of this fictitious line that you are. And these lines of longitude, while they go vertically around the Earth, they measure how far east or west you are. It's kind of weird. So even though latitude lines that go sideways laterally, you're measuring how far north or how far south of the equator you are. Longitude lines, while they're vertically on Earth's surface, they're measuring how far to the west or how far to the east you are. A little reminder, or a little way to remember that is a ladder. All right, kind of sounds like latitude. So for a ladder, the long sides of the ladder are the ones that go up and down, just like lines of longitude. Long side of the ladder, long lines, longitude, up and down. The rings of the ladder, the actual things that you climb on the ladder, whether you go up or down, those represent the lines of latitude. Just kind of a way to remember it. So, what does all of this have to do with anything? Okay, well, we're going to get into a little meteorology and climatology and atmospheric science. I'll try to keep it as brief as possible. Hot air balloons. Well, you heat up the air in the balloon, hot air rises, cold air sinks. It has to deal with density. Hot air is less dense, so lighter, so it wants to float. Cold air is more dense, heavier, so it wants to fall. Okay, so let's start with there. So around the equator, that receives most of Earth's, the most solar energy on Earth. So the area around the equator is going to be very warm, including the air. So what does hot air want to do? Hot air rises. All right, so hot air rises away from the surface. So you get around the equator, you get this area of rising, warm, moist air. As that warm, moist air rises into the atmosphere, it cools down. Remember, cold air can hold less moisture, so therefore the air just releases that moisture. So that hot, moist air rises, but as it cools, it loses the ability to hold that moisture, so it drops that moisture in the form of rain. So now what you have peeling away is now kind of this this air, and as it gets further away from the equator, it cools down. It can either go north or south. We'll just kind of follow it north because the process is the same, whatever. So I get this warm, moist air cooling down. As it cools down, it releases moisture. And as it cools down and cools down, what does cold air want to do? Descend. Hot air rises, cold air descends. So you get this hot air rising, cooling down, and as it cools down, it's losing its moisture. So now it's cold, dry air that descends right around this area of 30 degrees north as well as 30 degrees south. You with me so far? Where else is it cold? Well, around the poles. So the air there is going to be cold. And what does the cold air want to do? Sink. All right, so cold air descends. All right, stick with me. So now I got cold descending air over the pole here, and it can either go kind of off to the west or to the east. Well, now again, I have this cold air descending around 30 degrees latitude north, and that can either head north or south. So let's continue to follow it north. So I got this cool air. As it descends, it's warming up. So now we have warm, dry air because all the moisture was lost back here. So now I have this warm, dry air peeling north, and what does warm air want to do? It wants to rise. And then when it hits this cold air coming down, it wants to rise. So we have this area, again, around 60 degrees latitude now that has been warmed up, that has risen up. So now you have rising moist air collecting moisture as it moves north over whatever area of moisture or water it might have. So you have areas of warm, moist air rising where you're going to get a lot of rain, a lot of precipitation, but you have areas of the globe where cold, dry air is descending. Cool air holds less moisture, so this descending air is very dry. So any area kind of under 30 degrees north or south is going to exhibit very dry air, desert regions. Same thing with around the poles. All right. You're confused? Let's see if this makes sense. So here is around 30 degrees north and south. Do you notice what's in these boxes? Deserts. That's due to this area and how the weather patterns work around the atmospheric patterns work around the globe. In general, you have this descending dry air over these areas, which creates the deserts. Same thing in the poles. All right. Again, Antarctica is the world's largest desert. Why? It's cool, dry air. Well, there's a lot of ice. Well, yeah, but that ice has been there for a long time. So whatever little precipitation it gets, it's just built up over millions of years. There you go. And here we are in Arizona, right in the thick of that box. So if we're in this box around 30 degrees north and south, that would make it subtropical deserts. If we're in this box up around the poles, that would make it polar deserts. Go figure. Again, right along the subtropical 30 degrees north or 30 degrees south, some of the world's largest deserts, most well-known deserts, Sahara Desert, the Sonoran Desert in which we live in the southern hemisphere. You have like the Kalahari Desert, the Great Australian Desert, but also these cold polar deserts. Antarctica, again, the world's largest desert. So those are two of the 5 types of deserts, subtropical and polar. Then you get continental interior deserts. These are found in the heart of continents. They exist because they're just so far away from any large bodies of water, like oceans, that would provide any moisture. So they're just so far away from a moisture source that when weather patterns do reach these areas, there's just no moisture. All that moisture has been gone for hundreds of miles. So that they're just too far away from a moisture source. So the air that does eventually reach them lost all its moisture, so it's dry. Therefore, we create these arid desert regions. These deserts are found sometimes well over 1,000 miles from any ocean shore. So these really only exist kind of in one-ish spot. Asia is just so large. There's parts of Asia that are just so far from the ocean as you're getting way up into the interior of Asia that just no moisture-rich air can just get to them. Rain shadow deserts, the fourth type. So they exist near the leeward slope. That's the side of mountains facing away from the prevailing winds. So they exist on the leeward slopes of some mountain ranges. I'll show you a diagram here in just a second. So if you have a mountain range and you have some moisture-rich air that hits the mountain range, it's forced to rise. As that air rises, it begins to cool. As that air rises and begins to cool, it loses its ability to hold moisture, so that moisture falls on the what's called the windward side of the mountains. And as that air continues to go up and over, it's now cool, descending dry air. So now you get this dry air descending onto the other side, the leeward side of the slopes. So there's little moisture by the time they get pushed up and over mountains because that air cools, loses its moisture. So here's a great example. So you have warm, moist air. It's forced to rise up and over a mountain range. Typically, these mountain ranges are near coasts. And so as that air rises, it begins to cool, loses its ability to hold the moisture, so precipitation occurs. By the time it moves over the mountains, it's dry air. As it descends, it warms up. So on one side of the mountains, you can have very lush green areas. On the other side, desert. This is very common up in Oregon and Washington. You have the Cascade Mountains, and you have this moisture-rich air hitting the coast. So places like Seattle and Portland are all lush and green and have all kinds of rain. But as that moisture goes up and over the Cascade Mountains, the other side, most of Washington, most of Oregon, is the desert, is a high desert. It looks very different than the coasts. Same thing kind of South America, just as another example. There's a number of these. Moist-rich air hitting the coast, hits the Andes Mountains, very high mountain range, goes up and over, it cools, loses its ability to hold moisture, so as it descends on the other side, dry air. And then we have coastal deserts. Coastal deserts are only found on the coast. If a desert is only located on the coast, good chances it's a coastal desert. Cold ocean currents are what contribute to the formation of coastal deserts. See, all of this has to do with water. Hence, it's in this kind of last part of the semester when we're talking about water. So you get warm air blowing towards shore, and it's cooled as it goes over the cold ocean currents. The atmosphere and the ocean currents, the surface of the ocean, interact very well with one another. So if you have a cold ocean current and warm air moving over it, well, that current's going to cool it down. As it interacts with that cold ocean current. As warm air cools, it loses its ability to hold moisture, so it's going to drop that moisture, and then as it moves onto land, it's now dry. Any moisture in the air condenses as rain or sometimes fog. So foggy areas usually have cold ocean currents just outside of them. Think San Francisco. There's a cold ocean California current that comes down the coast of California. When any warm air goes over it, it cools. Fog occurs. Very foggy in San Francisco. So then the air moving onto shore then is thus dry. So again, you have the cold ocean current. Air moving over it cools down, loses its ability to hold the moisture, so creates rain or fog, and as it continues to move inland, it is now dry air. So very generalized map of some of the currents around the world. So in general, weather patterns move from east to west around the equator and kind of the northern reaches and southern reaches of the hemisphere. But in general, kind of in between, they move from west to east. And that becomes important. So you get, for instance, a cold ocean current. Cold ocean current, when that air moves over, it's chilled, becomes dry. So when it hits the coast of for instance, South America or the coast of Africa, it's now dry air, creating an arid region. So you have the cold ocean current, warm air moving over it, cools, becomes dry, hits the coast, creates coastal deserts. Same thing in Africa. We have a cold ocean current moving this way, warm air moves over it, cools down, loses its ability to hold moisture, so when it hits the coast, you can see here, very dry. All right, we'll go ahead and pause there for now. When we come back, we'll talk about the different types of landforms that are created. Similar to what we did with glaciers, erosional, and depositional landforms, we will do the same for deserts. I'll see you all in just a second.